There we go. So we're going to be doing the standard to apply and extend previous understandings of arithmetic to algebraic expressions. So we're going to be basing your previous knowledge onto more advanced stuff with algebra. So we're going to be able to find the area of right triangles, other triangles, special quadrilaterals, and polygons by composing into rectangles and disposing into triangles and other shapes. Applying these techniques in the context of a real-world mathematical wizard. Or, in other words, so in your I will be able to. Yes, it is. You're right.
And you're recording.
I'm not going to be recording Marty's voice, though. No. It's obnoxious. It's obnoxious. So we're going to be able to apply algebra to geometry. That's what you're going to be able to do. That's the easiest way to put it. Apply geometry. Well, apply algebra to geometry. So that's what you're writing. Right there. Cool. Apply algebra to geometry. Yeah.
How do you do that?
All right. So this do now, we are going to be talking about explain and define each property illustrated. So on the homework over the weekend, which one is where we have 6 plus 5 equals 5 plus 6? Question, Tommy? What's going on?
Yeah, I'm not done with my other
Oh, well, we're doing this now, so you do this.
Okay.
But Riley will get that back from you. Avery? Commutative. Commutative says it's in a different order, okay? It's in a different order. It's still the same community, it's just in a different order, right? Because it's a community of 5 and 6, and then it's 6 and 5. Then we have something where we have parentheses. Which one is the parentheses? Sydney? It's associative. The 4 and the x are associated together because of the parentheses for the first one. And then the next one, we have 9 and 4 that are associated together. Then we have, so it's the associative property of addition. Associative property of addition. And then we have the third one, which is Avery. Distributive, I'm going to disagree with you. There's no distribution of anything in there. Bradley? The associative property of multiplication, exactly. Because there's different things that are being multiplied together and being associated together. Good, good, good. So the distributive property, as a review, is a combination of multiplication and either addition or subtraction. Usually use multiplication and addition to solve. Like the way that I can multiply big numbers by big numbers, I use the distributive property. And we've talked about that a little bit in the past. Meant to be able to do math for larger numbers mentally with practice, and it simplifies expressions. So with using the addition, what does your notes look like on this? Okay, good. Using the addition property, distributive property with addition. Now I can speak. 5 times 15. You could look at it as being 5 times this the quantity of 8 plus 7. So see how it's easier to do 5 times 8 plus 5 times 7 there? Because you should know those ones, but you may not know 5 times 15 necessarily right off the top of your head. That's what we wrote down in our notes on Friday, which is the A times the quantity B plus C is equal to AB plus AC. Now, what's going on with that AB? What can you tell me about that where it says AB? What does that mean? Yeah. Yes, good. They're being multiplied together. Taylor? Yep, they're both variables, and they could be any number whatsoever, especially if it's an unknown. And the way to work that out, we could also do 3 times 4 plus 3 times 5. We go the other way around. We can put those together through the distributive property. So 3 times 4 plus 3 plus 5, then going 3 times the quantity. 4 plus 5 is kind of going backwards, so if we ever need to do that on homework. Then we could also have it be just any other Any other way, that's the way to represent that with any 3 or 4 numbers. Now with the subtraction, it's going to be very similar. Okay, you just change the sign. Let's see here. A second ago. Oop, I want to go back. Baby, go back. Now with this one here, this was like the homework that we did last night. Can someone tell me what I could do with the first one there? 7 times 29. How could I make that look like the distributive property? There's a lot of different ways. Yep, go ahead.
Wouldn't you go 7 times 2 and then 7 times 3?
And then?
No, plus 7 times
Plus. Gotcha. Plus 7 times 9. Beautiful. That is true. How about another way of writing it? How about another way of writing it? Whoa. Just threw my stylus. Yeah. 29 times, that would be, yes, that would be the commutative property. That'd be the commutative property. How about this? Doesn't this look a lot like the one that we had?
Yeah.
Right? Yeah. You can have anything in there that has the sum of 29. And if you wanted to get really crazy with it, you could even have something like this. Negative 370 plus would be 29. So there we go. Just showing you how diverse it could be, because that sum is 29. Yes, ma'am. Oh, yeah. Wow. There, I misheard it. I'm focusing on writing what you guys say and didn't even realize what we were doing. Then this one here, what can we pull out of that? What can we pull out of there? How could we make it look like the one on the right here? How can we make it look like the one on the right? Yeah. 26 plus 8. True, but that would be changing it a lot. How about the distributive property, though? How are we going to make it look like a distributive property? Yeah. 6 times 4 plus 8. Let's see if that would work. So we have 6 times 4, which is what? 24. Plus 48. No, that would be too big. But you're on the right track. That's the right idea. That's the right idea. Alma, what do you think? What can we pull out of there? What's the greatest common factor? It would be 7. So you should have the answers written down for what we did here. Yeah. 3? Let's try 3. I pull a 3 out. 3 times what is 6? 3 times what is 28? That'd be 21. Yeah. 7 times 4 would be it. So we didn't find one, but that now we're on the right track again. We tried 6, we tried 3. Those don't work.
2.
Okay, Quinn, what do you think? 3 was too high.
Oh.
Shh, stop shouting out. If 3 was too high, what can we pull out of both those numbers? What? 2. There we go. 2. There you go. We pulled the 2 out. Now with this next one, you could get just about anything in there, right? You could put just about anything in there. What would it be, Taylor?
6 times 50 plus 6 times 4.
Let's have it the same format as the one above it.
Oh, sorry. So it should be 6 times 50 plus 4.
There we go. It can be 6 times 50 plus 4. It can be 6 times 25 plus 28, or 29 rather. Okay. Any questions on that?
No.
Huh. All right, I want you to do that last one. Okay, you do that last one. It's very similar to the second one. And this is where knowing your multiplication comes in handy. What'd you get, DJ? Okay. Think about it. You're going to have a number and then a parentheses. You have an answer? You have one? Don't tell me. Don't tell me. All right, DJ, what's your thought process right now? Let's see. Can you explain what your thought process is? What kind of things you're trying, experimenting with, that sort of thing? And it's okay if you don't get the right answer. This is new stuff, and that's okay if you don't have the answer. But we'll see what your thought process is. Please speak up. Okay, and so you got a 3. You're going to try out a 3. And what made you choose a 3? You're correct with a 3. It does have something to do with a 3. Okay, so 3 plus 10 is 13, and you're wanting to work around with that a little bit. Okay, I like your thought process. I like your thought process, but you're not quite on the right track. However, that 3 that you recognized in there, there's going to be a 3 somewhere in this solution. Nikki? Okay. Ooh, I like it. Okay, he did 2 plus 1 times 13, and that's how he said it, so I'm going to write it like that. Ew, can you tell it's below my shoulder? Let's try that again. Y equals 2 plus... Wait, what was it again? 2 plus 1 times 13. Now, if this is true, it should equal the same thing as 13 plus 19, or 13 plus 39. What is 13 plus 39? 52. So 13 times 2 is what? 26. 13 times 1 is what? 13. Does that equal 52? Nope. Nope. What number are we going to pull out of there? What number is the greatest common factor between the two of them? Yeah. Yep. There it is. There it is. 13 times 3 plus 1. 1 plus 3 times 13. And I'm going to do it in that order because that's the way it sometimes shows up in the homework. Now, if I were to do 13 times 1, I have 13 plus 13 times 3, which is 39, and boom, look at that. I already know it's going to be the same. Good job. That's the best way to do it, right there. You can have it in a different order inside the parentheses. You can have the 13 in the front, but that doesn't matter because of the commutative property of multiplication. Yes, sir.
I had 13 and then I did like the 1 plus 3, but I just put 30.
So you did the...
Like that's solid.
No, because 13 times 30 is going to be 390. Yeah. Yep. Yep. Cool. Any questions on that? All right, let's get into some geometry. Yeah, we do. We have lots of time. So it says here, which expression makes the area of a diagram, or area of the diagram? Would it be 2 times the quantity 5 plus 3? Or would it be 2 times 5 plus 2 times 3? Or would it be 3 plus 5 plus 3 plus 5? What's your thoughts, Avery? 2 times 5 plus 2 times 3? So what makes you think that it would be the middle one there? Oops. Area equals base times height. Good. So we would have the base would be 5. The height would be 2. Right? And then, but that's only taking care of one of them. So we have to add the base times the height. So what does this one look like? The first one, second one, or third one? The second one. But isn't it the first as well? Yeah. Yeah, because we could pull these this 2 out and this 2 out. So it's now 2 times the quantity 5 plus 3, and that's what it is in the bottom left. Yes? No, it doesn't. Nope. I would actually like it to be like this, because that multiplication sign looks like just like an X. Cool? Look at us. So it's this one and this one. Okay. This one's better because there's only one height, but there's 2 bases, or 2 widths. And also, this is the one that we're actually doing in this lesson. So, area models. Which area models can be found by the expression 2 plus 3 times 4? 2 plus 3 times 4. Well, let's work out what these would be. First off, how would you find the area of this? Whoops. How would you find the area of C? How would you find the area of C, Sean? And as remember, to find the area of a rectangle, it's base times height. Good. 4 times 2 plus 4 times 2 plus 3. Good, because it could just be 4 times 2 plus 3 times 1, but you know that 3 times 1 by the identity property of multiplication is just 3. Okay, good. How about this one? What's this guy? Yeah.
1 times 3 plus 2 times 1.
Okay, 1 times 3, which is 3, plus 2 times 4. So we could, I'm just going to put it like this so we see what's going on. Okay, that's not this one either. How about this guy over here, A? Brooke? 4 times 3 plus 2 times 1. And I don't need that times 1 there because I know that's 2. Now, the way that Brooke just said that, that looks a lot like this, but it's not the same, is it? Okay? But isn't it the same? Yeah, it's just a different order. It's just a different order, okay? Through the commutative property, you can put the same community in different order. There's still that community. So the correct answer is what? A. A. Okay? A is correct. So write 2 expressions to show the area of this compound figure. So we're getting the purple area. See if you can do that. Try that out from what we've been doing. Ow, paper cut. It's tiny. Write 2 expressions to show the area of compound figure. Alma, what did you come up with? 5 times 5 plus 2 times 2. Good. Yes?
5 times 5 plus 4.
5 times 5 plus 4. So we just took it one more step. Good. That works. My watch is a minute and a half off now. All right, guys, have a wonderful day. No homework. We'll finish this tomorrow. I will post this video, but no homework. Make sure you have your homework tomorrow, okay? Yes. Yes. Actually, hey, I do have it. Taylor. Here you go. There it is. Goodbye.